Now it's time to learn some buyback tricks in this lightning talk by Zhi Ren Guoy. Adding buyback to the professional bots debugger tool set is the topic of this speech. Guoy is a software engineer at Fave, where he usually nerds out using Ruby on Rails. He is an agilist at heart, keen on exploring ways to work better by adopting a lean and agile mindset. He also tinkers with operations and infrastructure with the focus on improving continuous integration and deployment. And now, we will have a 15-minute crash course on getting started with the buyback debugger. Zhi Ren, please, floor is yours.
Hello gamers, I'm Guoy, and my talk title today is Adding Buyback to the Professional Puts Debugger Toolset. Before I start, I'd like to give a quick shout out to everyone involved in organizing Euruko 2021. Thank you for all the time, effort and work that went into this event. Also everyone, gentle reminder to follow the code of conduct. A bit about myself. I'm currently a Ruby on Rails engineer. I make terrible memes and bad puns. Don't worry, you'll see some of them in this talk. I co-host Copy Overflow, a monthly podcast about software development, and I mostly appear as Ghost Eat Human on social media. It's a pun on my name. I don't actually eat people. So I would assume most of us here in our day-to-day job ship working bugs. Oh, sorry, I meant features, working features. As part of that, we write tests to ensure our code is working. However, what do we do when we find something wrong with the program and can't really pinpoint it? Well, we'll usually read the code line by line, going through the logic and trying to decipher why the code isn't working. Maybe we can find out what's the issue just by reading the code. If we can't fix the issue just by reading the code alone, we then upgrade to become professional puts debugger. You know how it is, puts here, puts there, puts everywhere, and hopefully we can find out where the bug occurs. But what if puts is not enough? Another way would be to use a debugger, which is an application that allows us to run the program under controlled conditions. Let's take a look at this terrible example. This is a function that takes a user ID and a hash called referred. If it's the first time a user gets referred, they're not in the hash, they get a discount. If they have been referred before and already in the referred hash, they don't get a discount. Look, like naming things, I had a hard time thinking of an example. This code is deliberately bad for a reason. So at the end of this program, I sent a message with user ID 1 and an empty hash. I was expecting to get a discount. However, when you run it, it returns 0. Let's take a look at the professional puts debugger way. To see if it reaches a certain line of code, we use puts to help mark the execution path. As we didn't see any similar puts in the output, we know that the code did not pass through there. Let's take a look at byebug. It's a Ruby debugger gem and supports MRI 2.5 and above. It does not support other implementation like JRuby and Truffle Ruby. We can run byebug from the command line to debug a Ruby program without editing it. Running byebug on the program shows the file content, and on the left, byebug will show the number of lines and which line the debugger is currently at with an arrow. At the bottom, there will be a prompt where we can key in commands. First thing to know is what commands we can input, and what better way to find out than to call for help. The help command will show all available commands. Don't worry if you don't see this, we'll go through some of them. Quick note, quitting byebug is much easier than quitting Vim. Let's take a look at the list command. Using the list command, we'll show all the lines of source code, and we'll also show the line of code you're currently pointing at. In this case, it's line 1. Let's talk about the break and continue command. The break command sets breakpoints in the source code, and byebug will stop execution when it reaches the breakpoint. The continue command continues the program execution until the next breakpoint or at the end of the program. Let's take a look at the usage of break and continue. Based on the code logic, the program ought to stop at line 5. So we want to stop at line 5, and to do that, we need to set a breakpoint there. The continue command will then execute until the next breakpoint or the end of the program. We can see that the execution returns 0 at line 3 rather than stop at the breakpoint at line 5. The next command is like the continue command, except it proceeds to the next line instead of the next debug point or at the end of the software. We know that the program returns at line 3, and we can confirm that by using the next command by performing a line-by-line execution. Byebug also supports conditional breakpoints. We can get byebug to create breakpoints when specific conditions are met. As an example, I can set a breakpoint at line 3 if user has been referred before. Let's say we are interested to know the values of variables. Being a professional puts debugger, we will put the variables to print the value out. In byebug, we can type the variable on the console and it will show us the value at the variable at the line it is at. Here we can see that at line 3, user ID has a value of 1. Using byebug, we can also mutate variables on the fly. Here is another example program that prints the value of A. In line 1, A is set to 1, and we use next to move the code execution to the next line. We can then set A to be 42, and then at the end of the program, A has a value of 42. We can also use byebug to find out the scoping of variables. We can use this to know which variables have global, instance, and even local scoping. Here's an example showing local variables. There are times where we want to know when the value of a variable changes. For the professional puts debugger, this is where we have puts everywhere to track the values of a variable. Byebug provides another option. We can use the display command to show the value of the variables every time the debugger stops. The set command modifies byebug settings. Here, setting line trace allows us to enable line execution tracing. With these two commands, we can see the value of referred after the execution of every line. Well, seems like we found out where the issue is. The thing is, we all write programs that rely on gems, and this is where I feel that we're finally hitting the limits of being a professional puts debugger. Let's say we're using a third-party gem. In this case, it's our QR code, a gem to generate QR code. There's no way you can use puts to debug unless we have access to the source code itself. Even if we do, it's a hassle to clone the repo, add all the puts here and there, etc. etc. In this case, we can use byebug step command to get into gem methods. Here, we can see that byebug stepped into the code in the gem. Let's say we are stepping into all these methods in the gem, just trying to find out where the issue is, and we realize we are lost in the rabbit hole of code. We can just ask byebug where we are, and it will show us where in the execution path we are at. Lastly, using byebug in Rails. The byebug gem is included in Rails by default since Rails 4.2. In the code, call the byebug method to debug. The debugging will start at the line below the byebug method. And here are all the references I used to prepare for this talk. And that is all. I hope you all learned something today. Thank you.